Up to this point, we've been looking for values from a specific set to see what would make an equation true. But what about inequalities? Grade 6 is the first grade level where the term inequality first appears in the Common Core standards. Standard 6 NSC7A deals with inequalities. It states, interpret statements of inequality as statements about the relative position of two numbers on a number line diagram. In this same cluster of standards, 6EEB8 talks about writing inequalities in the form x is greater than c or x is less than c to represent a constraint or condition in a real world or mathematical problem. So this informs us that this type of inequality is what we will deal with. Something like x is greater than c or x is less than c, and specifically maybe something like x is greater than 9 or x is less than 9. But in looking ahead to the next grade level, 7th grade, there's standard 7EEB4B. And the types of inequalities that students will be faced with there are something like this in the form Px plus Q is greater than R. So it stands to reason that we need to prepare students for that and go above just the simple idea of inequalities like x is greater than c, and maybe something like x plus n is greater than c. So rather than just x is greater than 9, we need to do inequalities such as x plus 3 is greater than 8. Of course, we will have equations that model this, and those first inequalities dealt with greater than, but of course, we also need to deal with the inequality less than. So we would need to use inequalities such as x plus 3 is less than 8. So let's start off basic and have something like x is less than c, and let's specifically go with x is less than 6. And the set of numbers from which we can choose our solution are the whole numbers 0 through 10. Now for inequalities, it is definitely the best strategy to follow the standard, to use substitution to determine whether a given number in a specified set would make the inequality true. It's a lot more applicable for inequalities than it was equations. So following the standard, we plug in a 0. Yeah, that works. 0 is less than 6. 1 works. 2 works. And we keep going, and we figured out that, well, 0, 1, 2, 3, 4, and 5 work, but the rest of the numbers didn't. 6 is not less than 6, 7 isn't less than 6, and so forth. So our solution set would be the numbers 0, 1, 2, 3, 4, and 5. Let's try an inequality that's greater, and let's go with 7 is greater than c. Now, there's a little bit of a curve here because the variable isn't on the left-hand side, it's on the right-hand side. But students will have to get this type of experience. Okay, the set of numbers that we can choose from for our solution are the whole numbers 0 through 10. And students see, well, 7 is greater than, well, okay, I need numbers bigger than 7. So they just write, okay, well, that's 8, 9, and 10. That's our solution set. Now, here's the danger of not following the standard and not using substitution to determine our solution set. If we use substitution, we'll see that, hey, wait a minute, 7 is greater than 8. Oh, wait, no, it's not. 7 is not bigger than 8. Something's wrong here. So this is not the right solution set. Again, students might want to jump in and just quickly do these things in their head, but they need to use substitution, especially with inequalities. So following what the standard says, let's use substitution. So we plug in a 0. Yeah, that works. 1 works. 2 works. So we keep going, and we see that the numbers 0 through 6 work, whereas the numbers 7, 8, 9, and 10 didn't. So our solution set is 0, 1, 2, 3, 4, 5, and 6. Again, a good example here of the importance of using substitution to find your solution set. Okay, let's start off with our basic inequality, but let's make this a little bit more complicated to prepare students for what they'll face in 7th grade. Let's go with x minus y is greater than c, and specifically let's go with x minus 4 is greater than 2. And again, the set of numbers that we can choose from for our solution is the whole numbers 0 through 10. Now let's adhere to what the standard says. Let's use substitution. So let's plug in these numbers to see what works. And by doing this, we see that 0 through 6 did not make that a correct statement, whereas 7, 8, 9, and 10 did. So the solution set was 7, 8, 9, and 10. 7 minus 4 is 3, and 3 is bigger than 2, and so forth. Okay, starting with just the basic format of x is less than c, but let's ratchet this up a little bit, and let's go with something like 2x is less than c, and specifically let's try 2x is less than 9. The set of numbers that we can choose from for our solution set are the whole numbers 0 through 10. Follow the standard, and let's use substitution. Let's just plug in these numbers and see what works and what doesn't. So we plug them in. Let's see, 2 times 0 is 0. 0 is less than 9. 2 times 1 is 2. 2 is less than 9. And if we keep going, we'll see that 0, 1, 2, 3, and 4 work, whereas the rest of these whole numbers, 5 through 10, do not. For example, if I plug in a 5, 2 times 5 is 10. 10 is not less than 9. So our solution set is 0, 1, 2, 3, and 4. These values will make this inequality, 2x is less than 9, a true statement. Starting with our basic format, x is greater than c, we have something like x is greater than 12. But this time the set of numbers that we have to choose from is the set of whole numbers. It's not just a limited number of values to choose from like before. Well, let's use substitution. What will work here if we have all the whole numbers to choose from? Well, we'll see that, 13 is bigger than 12, 14 is bigger than 12, and on down the line. So our solution set will be 13, 14, 15, 16, etc. It just keeps going. Let's change the context a little bit, and the solution set can be chosen from the set of real numbers. However, this type of context is better addressed in standard 6EEB8. That one talks about inequalities in the form x is greater than c or x is less than c to represent a constraint or condition in a real world or mathematical problem. Now, given the set of real numbers, we're going to have, in many cases, infinitely many solutions. And standard 6EEB5 really doesn't address that. So we're better off, again, don't do these types of examples for standard 6EEB5 because, again, it applies better to standard 6EEB8. The reason being that, we're talking about from a specific set. Also, standard 6EEB8 deals with representing solutions of such inequalities on a number line diagram. And again, that's not part of standard 6EEB5. Now, what about inequalities such as x is greater than or equal to c, or x is less than or equal to c? Even standard 6EEB8 doesn't address that because it only deals with less than or greater than, not greater than or equal to and less than or equal to. When we compare, say, x is greater than c to x is greater than or equal to c, the only difference is the inclusion or lack of inclusion of your starting point. But again, that deals more with your number line diagrams. So again, this question is better handled in the future with standard 6EEB8 and not this particular standard 6EEB5. In looking at the standards for mathematical practice, looking at the first 4, students doing some of the activities to address this standard would reason abstractly and quantitatively. and they would also construct viable arguments and critique the reasoning of others. Looking at the last four of these standards, students would be attending to precision, and they would be looking for and using structure.